dear students. Last class we have discussed about the communication model, then types of connection, transmission mode, time domain specifications of a signal, time representation. So the time representation of a signal will include peak amplitude, phase, and frequency. So this is the general time domain representation of a signal. So as far as a time domain signal is concerned, you can see it is represented in time domain for a particular frequency. So a single frequency component is taken and it is plotted over time. So x-axis time, y-axis is the amplitude of the signal. So it is for a single frequency and how the signal varies in time. A single frequency component of a signal is varying with respect to time. So that is the plot of a signal in time domain. ഒരു single frequency component time domain എങ്ങനെ vary ചെയ്യുന്നു എന്ന് കാണിക്കുന്നതാണ് time domain representation. അതിലെ x-axis ടൈമും y-axis അതിന്റെ ആംപ്ലിറ്റ്യൂഡും ആണ്. So, but when we are looking into the time domain specification, we don't know how many frequency components are there in that signal, because a signal is a combination of different frequency components. A signal contains multiple frequency components. അതിലെ ഒരു particular frequency എടുത്ത് represent ചെയ്യുന്നതാണ് time domain representation. But there is no knowledge about the frequency components of that particular signal when we are looking into the time domain specification. So in order to understand how many frequency components are there in a signal and how that varies, that is represented by the frequency domain specification. So a signal usually made up of many frequencies, of which a single frequency component is represented in time domain. So we want to know how many frequency components are there in the signal. For that purpose, we are using the frequency domain representation. So this is a simple addition of frequency components. Two frequency components are there. Signal representations are given. When we add these two frequency components, we will get a waveform like this. So it is a composite signal with these two frequency components. So this is the frequency domain representation. Remember, a signal is made up of multiple frequency components. As an example, this is an AM modulated wave. When we are plotting the time domain wave into the frequency domain, it will have three frequency components, namely FC, FC plus FM and FC minus FM. So this is an AM modulated wave, and when we convert this time domain signal into frequency domain, to know what are the frequency components in that wave, we will get three frequency components, FC, FC plus FM and FC minus FM. So in frequency domain, this x-axis will be the frequency and y-axis will be the amplitude of that particular component. So FC is a frequency which is having an amplitude of VDC, whereas FC plus FM will have an amplitude of Vm by 2. FC minus FM will have a amplitude of Vm by 2. So these are the frequency components of this signal, or this is the frequency domain representation of the signal, which is known as frequency spectrum. So spectrum characterizes all the frequency components. It is this frequency domain specification of a signal. Now, for this signal, this is a time domain representation, and when we are taking the frequency domain representation of the signal, x-axis will be frequency, y-axis will be the amplitude. Usually power will be plotted across frequency. So 1F, 2F, 3F, 4F components are there. F is the fundamental frequency. So you can see For f, if let it be 1 kilohertz, if f is 1 kilohertz, it is for 1 kilohertz, the amplitude is 1.3. For 2f, there is no amplitude, that means 2f or 2 kilohertz sine wave is not there, 2 kilohertz frequency component is not there, but 3 kilohertz component is there with an amplitude of 0.4. Again, there is no 4 kilohertz component. So this is the frequency domain representation. I hope you got the idea. Time domain plot ചെയ്യുമ്പോൾ x-axis ടൈമും y-axis അതിന്റെ ആംപ്ലിറ്റ്യൂഡും ആണ്. ഒരു പർട്ടിക്കുലർ ഫ്രീക്വൻസി എടുത്തു കഴിഞ്ഞാൽ അതിന്റെ ടൈം ഡൊമൈൻ, അതിന്റെ റെപ്രസെന്റേഷൻ ആണ് ടൈം ഡൊമൈൻ റെപ്രസെന്റേഷൻ. ബട്ട് ഫ്രീക്വൻസി ഡൊമൈൻ റെപ്രസെന്റേഷൻ എന്ന് പറയുന്നത് അതിന്റെ എല്ലാ ഫ്രീക്വൻസി കമ്പോണൻസും അതിന്റെ ആംപ്ലിറ്റ്യൂഡിനനുസരിച്ച് പ്ലോട്ട് ചെയ്യുന്നതാണ്. സോ ദാറ്റ് ഈസ് വാട്ട് ഈസ് ഫ്രീക്വൻസി ഡൊമൈൻ representation. So from this you got, this is a spectrum of AM modulated wave. So for this is a spectrum of this wave. So spectrum means it is a range of frequencies over which the signal exists. That is what is spectrum. Now take the case of this signal. So this is an composite signal. We have discussed it earlier. It is addition of two frequency components. So if we are taking the frequency spectrum of this signal, this is the time domain representation, this is the frequency domain representation of spectrum of frequency spectrum of the signal. This is having a zero frequency component. That means zero frequency component means it is the DC component. DC component means you can see that the signal is clamped from zero amplitude. It is above the zero level, not below the zero level. It is above the zero level. So it is, but it is symmetric, but symmetric at about 1. Usually the signal is symmetric about 0, but this signal is symmetric about 1. So that means there is a DC component is there. A DC component can be, a DC value can be represented as an AC value with zero frequency. So if we are taking the frequency spectrum, there will be an amplitude corresponding to the zero frequency. Then for 1f, the amplitude is 1.3. For 2f, there is no component. For 3f, there is a 0.4 amplitude. If it is power, it is 0.4 watt. So that is the spectrum of this signal. And next parameter in the frequency domain representation is absolute bandwidth. Absolute bandwidth means it is the width of the spectrum where the signal is represented. That is, consider this, it is an analog acoustic spectrum which spreads from 10 Hz to 100 kHz, where the speech spectrum ranges from 100 Hz to about 10 kHz. So the total spectrum is spread over 10 Hz to 100 kHz. That is the absolute bandwidth of the spectrum. But if we are taking the speech, it spreads from 100 Hz to, let it be, 10 kHz. So the spectrum of speech signal is from 100 Hz to 10 kHz. 100 Hz to 10 kHz, within which the maximum amplitude is for this range. That ranges about 200 Hz to 1 kHz. So 100 Hz to 10 kHz is the absolute bandwidth, within which the maximum amplitude is for 200 Hz to 1 kHz approximately. So that is what is known as the effective bandwidth, or simply it is the bandwidth of the signal. Again, DC component is component of zero frequency. So any transmission system has capacity to handle limited band of frequencies. That limits the channel capacity or data rate of the system. So once again, time domain representation of a signal. This is the time domain representation. X-axis is time, y-axis is amplitude. Then frequency domain representation. This is x-axis frequency, y-axis is again amplitude. So zero frequency component is the DC component of the signal. Then parameters of frequency domain specification. spectrum, absolute bandwidth, and effective bandwidth. I hope you got the idea about time domain specification and frequency domain specification. Thank you.